Welcome to a new unit in chemistry. This is exciting because it means there's only one unit left to cover between now and the end of June, which means we're doing awesome. So the first part of this new unit is called electrochemistry. So electricity involving chemistry, but not electricity in the way that you think. We're going to be looking at our ions and their charges, and we're going to be doing something by stepping that up a bit. And so the other word that gets used instead of electrochemistry is called redox. Quite often you'll hear the term redox reaction, and so the RED is short for reduction and the OX is short for oxidation. So it's a reduction oxidation reaction. And that's just showing a give and take of electrons between ions. So when we are looking at sodium, when we turn sodium into an ion, it has one less electron, in its outer shell than does, say, chloride. Remember, sodium has 11 protons, which means that at the center, there's the protons and the neutrons. And then in the first level, there's 2 electrons. In the next level, there's 8 electrons. And in the third level, there's 1 electron because there's 11 protons in the nucleus. And so what happens is the sodium, it's way easier to get rid of this 1 electron than it is to try and bring in seven electrons, right? Sodium's a loner, it's an introvert, it just doesn't want to be anywhere, so it would rather kick out that one person than to bring 7 people in to make it happy. So then when we kick it out, we see that we have only 10 negatives, but yet we have 11 positives, and so sodium ends up with an extra positive ion, and so sodium gets that charge. If we looked at chloride ion, chloride has 17 protons in its nucleus, which means that here it's got 17 protons, neutrons. Then in the first energy level, it has 2 electrons. In the next energy level, it has 8 electrons. And in the third energy level, it has 7 electrons. And so, what does it want to do? Does it want to get rid of? Does it want to get rid of 7 electrons? Or does it just want to bring in 1 electron to make it an even party? It's easier to bring in 1 electron. And so what happens is when we do that, we end up with 18 electrons and only 17 protons. And so we have an ion balance, net balance of 1 negative. And so chloride ends up with a 1 negative charge. This is all Chem 20. But this unit takes that knowledge and elevates it. So don't forget this piece. If this piece is something you're struggling on, you need to come to me and have a conversation because you need to understand how this is working, this flow of electrons, this taking and this giving of electrons. Okay? I'll put that up there for future reference. All right. We're going to look at characterizing oxidation and reduction reactions. So oxidation typically was, the original statement was a reaction that involved oxygen. Well, there's a bazillion reactions out there that don't contain oxygen. And so the modern theory is that we call oxidation where we see a loss of electrons. Okay? So an oxidation is a loss of electrons. Reduction was where you take something like an iron oxide out of the ground and you would create pure iron. And so you are taking iron cations and you would turning it into iron atoms. And so to do that, you had to gain electrons. So reduction is a gain of electrons. So reduction is a gain of electrons. So this makes sense. If oxidation is losing electrons, then there's got to be something out there that picks up those electrons. Because we can't just have electrons willy-nilly floating around in the atmosphere or in our space. They have to belong to something. They don't just exist. Okay, they have to belong to an ion. They have to belong to something. So out of all of this, we get redox reactions. And so if one atom can be oxidized, then that means another atom has to be reduced. And so what we're looking at simply is a transfer of electrons from one product or one chemical to another. It's a transfer of electrons. Something is gaining what something is losing. And we call those redox reactions. So let's look at a reaction between aqueous copper 2 sulfate and zinc metal. So copper 2 sulfate and sulfate. We know that it says copper 2 plus and sulfate is 2 minus. If you don't remember that, you need to give yourself a refresher. You need to open up your data booklet to the periodic table. You need to find copper. And we see a 2 plus and then a 1 plus. And the 2 plus coming first means that that's the most common charge of copper found in nature. And then we go sulfate. Well, we don't have sulfate here, but we do have sulfate here. Sulfate has a 2 minus charge. Okay, it's a polyatomic. It's made up of sulfur and oxygen. And so we always want a net charge of 0. So 2 plus and 2 minus make a net charge of 0. So now it is critical that you remember how to balance compounds. If you struggle with that piece, you need to have a conversation with me and I will help you become proficient because it's foundational to this unit. I have faith in you. You can do it. I taught you it. I know you can do it. Okay, and then zinc metal. What kind of reaction does this look like? It looks like a single replacement reaction, Mrs. Pyre. Well, you would be correct. So we're going to get zinc sulfate and copper metal. Zinc. I don't remember anything, Mrs. Pyre. That's okay. You have a data booklet. When I look at zinc, zinc has a 2 plus charge. Sulfate has a 2 minus charge. 2 plus and 2 minus give me a net charge of 0. But I don't remember what state zinc sulfate should be in. Never fear. We have a solubility chart. You go across and you find the anion. There's sulfate. And I'm going to look for zinc. Do I see zinc in this bottom row? Nope. That means it must be in the first row, which means that it is soluble. This is totally a do as I say and not as I do unit. You must put your states in. I'm lazy. I don't do it. You must do it. And then we can do a ionic equation. We just finished doing these things. So zinc sulfur or zinc solid plus copper 2 plus sulfate 2 minus. It's going to give me zinc sulfate plus copper. And this is why states are important, because we can only break apart aqueous compounds. You guys are troopers at this. This is a total ionic equation. This is a tie. Total ionic equation. Now we want a net ionic equation. That means we're going to cancel out. Kind of sounds like Hess's law, doesn't it? So zinc solid on this side, no zinc solid on that side. We're going to keep this guy. Copper 2 plus on this side, no copper ion on this side. We're going to keep it. Sulfate 2 minus on this side, sulfate 2 minus on this side. Cancel. Zinc 2 plus on the reactant or product side, no zinc on this side. Copper solid on this side, no copper solid on that side. So what are we left with? Zinc solid plus copper 2 plus is going to give us zinc 2 plus and copper solid, a net ionic equation. Okay? You must know the difference between a total ionic equation and a net ionic equation. Total is everything. Net is only what's left behind. Net, like force net. Like the net for Hess's law. Okay? All right. This is an example of a redox reaction. I'll leave this up here so that we can refer to it. Do this. Do it the easy way. Okay. This is an example of a redox reaction because we can see an electron transfer being observed. Zinc loses an electron to become positively charged. It actually loses 2 electrons because it goes from a 0 to a 2 plus, which means the electrons left. Copper ions gained electrons because it became neutral. See, we have a 2 positive down to a 0. So some electrons came and joined the party. So the copper 2 ions are reduced. So this is what we do. This is how we write a redox reaction. We start out with our net ionic equation plus copper 2 plus. See, I already told you I was lazy. I forgot to put my thing in there. Okay, this is our net ionic equation. When we look at the zinc to the zinc, we're only going to compare zinc to zinc, apples to apples. This goes from a 0 to a 2 plus. In order to do that, you have to lose 2 electrons because we're going from 0 to 2 plus. When I look at copper, I go from 2 plus to 0. Well, then I must have gained some electrons. Okay? So this one here loses 2 electrons. This is our summary. Zinc loses 2 electrons, which means that it's oxidized, and which means then I'm going to throw a new word in there that we're going to talk about, but I'm going to throw it in there right now, that this is a reducing agent. Okay, it reduced copper. Copper reduced, right? It's a reduction reaction. This is an oxidation reaction. So what happened to copper? Copper gained electrons. Well, we can't see that very good. It says gained electrons. It says that it was reduced, and that means that it must be an oxidizing agent. Okay? All right, let's talk about this reducing agent and this oxidizing agent. You really can't see that. Okay, it's an oxidizing agent. Okay, let's look at that. What do those mean? Since the electrons are transferred from the zinc to the copper 2 ions are responsible for oxidizing zinc. So a reactant that oxidizes another is called an oxidizing agent. So a reactant that oxidizes another is called an oxidizing agent. Okay? The oxidizing agent, therefore, is reduced because it gains electrons so that the other chemical can lose electrons. The zinc atom is responsible for the reduction of copper ions, and so zinc reduces copper. It's called a reducing agent. So a reactant that reduces another is called a reducing agent. So the reducing agent is oxidized right here. The reducing agent is therefore oxidized, and the oxidizing agent is reduced. And I have this beautiful little mnemonic. Mnemonic are letters in a rhyme or a pattern that help you memorize things. Metals, this is key right here. Metals tend to lose their electrons, and nonmetals tend to gain electrons. And atoms are neutral. That's why states matter. Okay. Leo the lion goes grr. A loss of electrons is oxidation. Oxidation. And a gain of electrons is reductions. I'm going to take it one step further. If you have a loss of electrons and you're looking at oxidation, that must mean that it's a reducing agent. If you have a gain of electrons being reduction, that one is the oxidizing agent. So these are the two things, these are the two mnemonics I want you to remember. A loss of electrons means that it's oxidation, and that atom or that compound must be a reducing agent. A gain of electrons is reduction, and that reactant must be an oxidizing agent. And it gets you to stop this. This is, even though this lesson is only 2 pages long, this is a boatload of information that you need to process. And I want you to do these. 437, 1, 2, 3, 4, page 440, 1, 2, 4, and 7.